Okay, so welcome everyone to the second Python course. This course is about using Python for testing, and we will be focusing on just two aspects of that: using Python unit tests and using Python with board farm, which is the testing that we are using for prplMesh. So I will be doing the first part, which is basically a generic introduction to using Python to develop tests with the unit test framework. Most of the test frameworks in Python are actually based on Python unit tests. So, so learning about unit tests is definitely useful, almost regardless of which test framework you're using. There's a couple of exceptions, a couple of frameworks that are not based on unit tests, but some of the same principles still apply, and so it's useful to learn about it in any case. As I mentioned, the presentation is split into two parts. So the second part will be given by Vitaly. And I will just tell you how to use unit tests to create tests and run them and to parse the test output. So the Python unit test module is just part of base Python. It's in the basic Python distribution. You don't have to install anything extra for it. And despite the name, it's used for more than just unit testing. It's also used for integration testing, whole system testing, and many other kinds of testing. So there's a couple of base classes. But rather than give a whole bunch of slides about this, I think it's preferable to just show a couple of examples and get a bit of feedback. And so I'll show you the code that I have and ask you to follow along, try it as well, and to ask any questions you may have, and then we can work together on the code and fix any problems that we see and work together on the whole system. So I'd like you to follow along and download the code here. It's in this Git repository, gitlab.com/f-van-bogaert/python-intro.git. So I will paste that in the chat, so it's a bit easier for you. Okay. Another thing that you can do is to just go to gitlab.com/f-van-bogaert/python intro. So that's here. And you can then just click here on the download and download it as a zip file or a tarball or whatever, and use the file from there or extract it from there, and then you can follow from there. You will need the Python interpreter, same as last time, and you will, and that's it actually, yeah. So if we take a look at the code, it's a bit different from the last Python course. So I've arranged it into a top-level directory called tutorial, and it has the directories examples and tests. So if you look at examples, we see the examples that were used in the first Python course. So the hello world examples, the math example, the subprocess example, the example of how to use classes, and so on. So we see, for instance, here, intro 8classes.py. There we defined an image class, which is just a two-dimensional pixel container, where the caller provides the pixels, and the class itself is just an accessor, basically, where you can get the pixel at a certain coordinate and set the pixel at a certain coordinate, and it has helper functions for determining the width and the height of the image. And that is actually one of the first things we will be testing today. So we'll be creating a unit test for this class. So let's, okay. Before we get started though, there is one other thing that I'd like to point out about this organization. So I've organized everything nicely into a modular structure. So we have the tutorial directory at the top, along with a couple of scripts here that run so this is the first script that I use to run the various tests that I will be developing. And you can see here the directory structure a bit reflected. So we have tutorial.tests.test01. And how it works is within this directory tutorial, there is an init.py script, which is just completely empty. It's an empty file, but it tells Python, just the fact that this file exists tells Python this is a Python module. So, and that means that I can use the import statement to import this module and the various components of the module. So you see here also the init.py file. So that's important if you want to structure your Python code base a bit more. So this is something that is new compared to the Python course that we had. And also, if you then look in the examples directory here, I've also added the init.py empty file. You can, by the way, put things into the init.py script. And if you import a module, everything you put in the init.py will also be loaded. So you can put some class definitions in there if you really want. So let's take a look at our first example here, our first test in Python. So like I said, we want to test this image class. And the first approach that we can use is outlined here, and it doesn't use unit test at all. What we can do is simply use the Python assert statement. So the idea with tests like this is we have some kind of reference data that we can use. In this case, our reference data is simply the data that we pass into the class here. And then we can run assertions on that, and we say, okay, the get pixel should return 1 for this location. The get pixel 11 should return this value, and get pixel 22 should return this value. So let's run this test. And we will run it using the run test.py script here. So what I'm doing here is from tutorial.tests.test1 import the main method as test01. So I will just import the main method here from this module, and then I will run that main module. So the ability to rename things as you import them can be quite useful. So if I had a test2 with a main method, then I can distinguish between them using this as by renaming them. Anyway, let's run test number 1. Okay, so I've run this test and it says, get pixel 22 is 46, pixel data was not set correctly. This assertion fails. Okay, so we have an assertion error, pixel data was not set correctly. So we can search here in the test and see on this line, okay, it fails here. Image.getPixel22 is 46, pixel data was not set correctly. So can anyone tell me why it fails and what we can do to correct it? Like I said, I want this to be a bit interactive, so I'm going to
please return back to the code. Okay.
What is that?
Yeah. So you have set you have set the wrong pixel So you set 55 to the place, and then maybe
Yes,
this is a problem.
yeah, indeed. So I wanted to test here that the set pixel works correctly, but here I just copied the assert statement from the previous line without changing it. So that's a common mistake to make in the test. So let's just fix that. Okay, and now it prints everything works. So now the test works correctly. So this is one way of doing tests in Python. It's kind of the naive way of doing it. It works, but it's a bit tricky because for one thing, if you get something wrong in your test, you don't get a lot of information about it. So if I change something, and here, so we know that this should be 66, not 65. But if you just look at this backtrace here, it's not clear really what the problem is. Right? You have to really look at the code and see, yes, this is apparently supposed to be 66. So we can do better than that. Also, really, there are several other things that we could fix, like really what we should be doing is comparing the array directly like this, so that we don't hard code the values here in the test. That's also something that would be better to avoid potential errors. Okay, so I've shown you one way to do it. Let's take a look at a more canonical way to do it using Python unit test. So we have the same example, but using unit test. So the first thing we can see here is, well, I'm importing unit test, and I've put everything in a class, which I call image test. So this class exists specifically to test the image class that we had before. And it is derived from unit test.test case. So this is a common pattern that you will encounter with unit tests. Is you will have a series of test classes that are all ultimately derived from unit test.test case. And in here you can see I have a couple of methods. So I have the setup method, I have the test initial data method, the set pixel method, and a test dimensions method. The setup method is always called by the unit test system itself before it runs your tests. And then the other methods here that start with test, those are the actual tests that I wrote. So the unit test framework requires that all of your tests start with test. So they are actually called test something. And it doesn't matter what the actual name is, so long as it starts with test. So I could call it test blah, 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 and it would also work. But of course, it's good to give it a descriptive name. So I've put in here code that is exactly the same as before. So yeah, that's what a test class looks like in unit test. And if we want to see how we actually call that, what we do is you can just call unit test.main, and what unit test.main will do is it will see all of the, it will look and see all of the classes you've defined that are derived from test case. It will detect them, and it will automatically run them. So it will call your setup method, and it will then call all of the test methods that are defined in your classes. So the unit test framework really does a lot behind the scenes. So let's take a look. If I now call run test again, I forgot I should import unit test here. Okay. So what can we see here? It's there are 2 dots and an F here. And then it says fail, tested pixel. And then it says it ran 3 tests in 0 seconds. Failed with failures is 1. So what does all of that tell us? So here, the dots tell us there were 2 tests that ran successfully. And then finally the F says there was 1 test that failed. So it was the 3rd test that failed. Here we get more details about the test failure, that this is what it looks like. And then here it gives a summary, again, saying it ran 3 tests, how long it took, and how many failures there were. So it says tested pixel failed in our test class image test, which is part of tutorial.tests.test2 module. And so it failed on line 25, as you can see. So it's the same error as before here, it's just a copy error. So we can fix that easily. So if I fix it, then we see there is another problem. So
can you please, I'm sorry,
yeah.
Can you please return back? I didn't see what you have fixed. It was so fast.
Yes, so let me zoom in a bit, that will also make it clearer. So what I had before was this here. So in tested pixel, I have a method, get pixel 11. It tries to make sure that it's 66. Then it sets the pixel to 55, and then it asserts that the value has changed, but I have the wrong value here.
Okay.
And actually, I also have the wrong thing in here, so I should be checking like this. Okay. So yeah. So I had 46 here. It should be 55. So I fixed that. And then what the method does is it tries to set the pixel out of bounds and then check if it causes an exception, because that's what we want. So I just ran that, and it says, okay, the test fails, and it fails with an assertion error, because yeah. So I erased here the assertion error based on the previous exception, but actually this is wrong, because we want the exception to happen. We actually want it to fail if the assertion doesn't happen. So one thing that we can do is say assertion happened is true, and before we can say something like assertion happened is false, and here we can say an invalid call caused an exception. And it's not assertion, it's exception, but I should call it. Yeah.
But it will not work, because you wrote exception in wrong place. So because we have the tabs between the other namespaces. So I think maybe you should put tab before assert in 32 line. So it should be under.
Fine. No, that's not what I want to do.
So it should not be under exception. Okay.
No. So what I want to do is I want to make sure that the method causes an exception. So what I do is I have a valuable exception happened that will be set to true in the exception handler. And here I want to see, make sure that this happens. And if it's false, so if the exception didn't happen, then I want to say, okay, this is wrong. So let's try that. Yeah, okay. So the exception did happen, and we are happy. If we do something like this, then we won't get an exception, and so the test will fail. So this is kind of inverting the behavior. We actually want the exception to happen because that's the part of the expected behavior of the class. Okay, so this is one way to write your unit test code, but it's still a bit tedious. So let's see, we do have a better way of doing it. But first, I see that there are possibly, yeah, the meeting is being recorded, Alex. Yeah. Yeah. So first of all, are there any further questions here before we continue?
Just a small question, maybe it was already asked, but is this the same approach we use in BotFarm?
There are certain things that you will recognize in BotFarm. So BotFarm is based on unit test. So some things will also be present there in BotFarm, yes. Okay. But I'm trying to build it up, right? So I'm trying to work towards it. So yeah. Anything else? Okay, then we can move on to the next example. So once again, we are testing the image class here, but now I'm doing it in a bit of a different way. So unit test has several methods here. Assert true, assert false, assert equal, and assert raises you can find here. So this is a different way of writing the same thing. I didn't add any tests here, but there are several advantages compared to the previous one. So if you write just assert, then you are only testing that this expression is true. But if it fails, then you don't know why it fails. You don't get any information on what the exact value was that you got. So that's not very useful. If you use the assert true, however, and the value is not what you expected it to be, then you get, sorry, the assert equal. If you use assert equal and you get a value that's not what you expected it to be, then the error message will actually print out what the value was. So you can write this code in two ways. You can write it using assert true or assert equal. Assert true is basically the same as before, as we did here, but assert equal just gives you a lot more data if it goes wrong with how it went wrong, because you get the exact value. And there's other useful methods as well. So there is, you can test not just that it's equal, but you can also test that it's not equal to some other value. You can also, there is also assert greater and assert lesser, I believe. So you can test if a value is greater or lesser than a certain threshold value. So there are a lot of these assert methods. In here, I'm just using assert true, assert equal, and assert raises. So assert raises is a bit special. Here we can say we expect to get an index error when we do this thing. And it uses the with syntax, so the same syntax that you use for opening files. You also use that with this kind of testing for an exception to happen. So we can run this code here. Let me just change the run test here again. Okay. And so we see here self.assert equal get pixel to 46, pixel data was not set correctly. And what it tells you is assertion error 55 is not equal to 46. So this is what I told you about. It gives you a lot more data about what went wrong because it tells you the exact values involved. So that is just a very useful aspect of these kind of tests. So indeed, it's the same error as before. I forgot to change the value here. Oops. Okay. So now it runs okay. So we can also test this this assert raises here. What happens if the code doesn't raise an exception? Then it says index error was not raised. And what we can also test here is what if we raise some other kind of exception? Well, then we just get the exception, I guess. So it still fails. So that's also a very useful thing to use here. All right. Yeah. Okay. And then for the next thing I'd like to demonstrate, I am going to give first a code example. So I have here a class called temp_file. This is a file for a class for helping work with temporary files where you can just write some lines, some strings into a kind of buffer and then read them back, basically. But it uses a file as a backend. So what it does is you can provide a file name, and if you don't provide a file name, then it will generate one for you. So it calls the file /temp/dummy and then a number, and then increases that number each time. And you can provide an encoding, and if you don't provide one, then it will select UTF-8. And so we open the file with the encoding. And in the destructor of the class, so this is how you define the destructor in Python, by the way. In the destructor, we make sure to close the file. So that's also very important. We wouldn't want to leak any file descriptors. In the write, then we have the write method of this file, and it will use the print method to print the string to a file. And so it will use the encoding that we provided here to encode the file and then print it to the file. And we also have a readline method that will read a line from the file. So the intention is, if you haven't read from the file before, then we will first seek to the start of the file before we start to read the lines. So the kind of pointer, the read pointer, is first set to the front of the file before the first time you call readline, and then the next time you just read the line after that, and so on. So this is just an example to demonstrate the testing, and as can be expected, this class has a number of bugs. So I hope you've already discovered a couple of bugs, but please keep them to yourself. Yeah. So we will be using the Python unit test framework to write tests for this class. Okay, any questions? Okay. So this is what my my tests file looks like for that temp file class. So here you see we import temp file. So we do need the temp file class to test it. And what I have is I have created a base class for tests called common base that is based on test case. And I then have two classes derived from that common base class. And I've done it that way because I have a setup and a teardown method that should be executed for all of the tests, and I don't want to repeat that in all of my tests. So this is one way of organizing tests where you can use subclassing to kind of to abstract away common functionality from your tests. So I have these tests here, test classes, temp file writer tests and temp file reader tests. They all only have a single test in them, but I could add more here. So we could have a test multi-line, right, for instance. So we could define more tests here if we want. So my idea with splitting it up like this is the temp file writer tests will contain tests that test the write method of the temp file class, and the reader tests will contain tests that test the read functionality, so the read line functionality of the temp file class. So this is just one example of how to split up these tests. Of course, you don't have to split them up. You could put them all in the same class, right? So you can just do it like this and it will work as well. But I like to split up these tests in multiple classes. And typically what you would do in a real program is put each class in a separate file. So I've put everything in the same file here for clarity, but normally I would expect to see this class in a file of its own, this class in a file of its own, and this class also in a file of its own. So that just makes everything more readable, especially if you start to have not just one test, but 5 tests or 10 tests or 15 or 20 tests. You want to split them up and organize them in a logical way so that it remains readable. So what you do is you group them together in functional blocks that test similar functionality. And you can do that by creating a test class for those groups of functionality, and then each individual test is a method within that class. And then we have a concept called test suites, and that you can also use. So in here, what I've done is I have created a test suite, unit test.test suite here, and I add 2 tests to that, and that is my test suite. So a suite is basically just a grouping of tests. It is a way to group tests together so that I don't have to write code like this all of the time. So I don't have to write import temp file writer test, reader test. It's just again, it's a good way of organizing these tests and grouping them together. Anyway, we can yeah. So what we could do is just import the tests directly and call unit test.main. But instead, what I'd like to do is I'm just going to import the test suite. So I have this suite method. It returns a test suite. And what I can then do is I can just say, okay, unit test, give me a test runner, and then just run the test suite like this. So if we do that, then we can see a whole bunch of errors. All of the tests are failing. So now comes the fun part. We get to debug the test class. So this is, again, something where I'd like the assistance of you. So let's work together to solve the problems here. So does anyone know what's gone wrong here? So I have here in test basic write self.assert equal contents self.test string. So let's take a look at what went wrong here. By the way, let's restore the file as it was. Actually, yeah, I messed up. I deleted a bit too much here. Oh yeah, okay. So yeah, here we are. Okay, so for clarity, let's run this again. Okay, it's slide 26, test basic write. This one goes wrong here. So what is this test doing? We are writing a test string, hello world, using self.temp_file.write. We are flushing this file. We are then opening the file again. We are reading the file and we are testing that the contents that we've read are the same as the test string. And when we do that, we see here b hello world is not equal to hello world. So what is going wrong? So I've called write with hello world here. So it does print contents.encodes. So contents is the hello world.encode in the encoding, and it prints to the file. Okay, does anyone have any idea what is going wrong here? So once again, this is the string that we are getting, and this is the string that we are expecting.
Start with the new line chart not working.
Mario, can you speak up? I didn't hear you.
Start with the new line chart is not included in the output.
Maybe
By the print function.
Mario, you are really, really quiet for me.
maybe bad encoding, or you just used Cyrillic O or other letter from Cyrillic in the Latin. So
Vladislav, the encoding has something to do with it. Mario, I think you said something about the new line, correct? Because that's
correct. Yes, it is. I don't know what's happening with my computer.
Okay. Yep. So you are both on the right path. So what I've done here in this file is I've opened the file with the encoding specified, so that's UTF-8. So that's good.
but you opened ASCII file, yeah? Because
No. So this is a new file. We created a file with that encoding.
Okay.
So what's going on here is is simply I've opened the file with this encoding, but I've opened it in text mode. I didn't open it in binary mode, so I don't need to encode the contents of the string because it's opened in text mode, so it will automatically convert it to binary using the encoding. So this step here is redundant, and actually what it does is it converts to a byte array and then back to string, because print works with strings. So what happens is the contents get converted to a byte array and then back to string, which is why we have this B here. B hello world instead of hello world. So that's one problem. And then and so we can fix that by removing the encoding here. It's not necessary. That was a bug. Okay. So let's try that again. And we see here, now what we have here is we get hello world and we expect hello world. But if we look closer, then actually what happens here is we get hello world with a new line and we expect hello world without a new line. So what's going on here is the print statement automatically adds a new line unless you tell it not to. So that's another bug of our class. So we can fix it like this. If we do it like this, if you specify what character it should add at the end, then it will not automatically add a new line. So we can tell it the end character is nothing. So it won't add anything. And if you do that, then the error is gone.
It looks like this is a hack when you put end character by hand.
You can call it a hack. There are other ways to do it. I think you can do self.file.write contents, something like this, instead of the print statement. I'm not sure actually. Let's test it. Yeah, so that also works. And that is actually simpler in this case than using the print statement. So we can just do it like this. And that way we don't have any problems. Yeah, Mario, new line character, indeed. I see it in the chat now. Okay, so we solved the bug, so that's good. So now we have the next bug. I have here assertion error, file cleanup failed is the next bug. So one thing that I did in the, yeah, so maybe I explained it briefly, but let's go over it more thoroughly. So for each test, what the unit test suite does is it first calls the setup method, then it actually calls the test in question, and then it calls a teardown method to get rid of the temporary environment that you set up for the test. So what we've done in the setup method is create our class, and what we do in the teardown method is delete our class. And one of the things that we want to test about the temp file class is it should remove the file once you remove the class, and that is not happening here. So what we do here in the destructor is we close the file, but the file is not actually removed. So that's our next bug. So we can add here os.remove self.filename. Okay. And if I do that, then I should remember to import OS. Okay, so that's good. We are now passing the file writer test. So that's nice. So test basic write, this test is now passing. So we have verified that if we use this class to write something, then it actually appears in the file. So that's good. And next, but however, the next test is failing. So let's take a look at this test. In this test, I am using tempfile.write to write a test string 3 times to the file. And then I am reading that line 3 times and making sure that that what we get is the same thing that we put in. So we put in here test string 0, test string 1, test string 2. So hello world 0, hello world 1, hello world 2. And we can actually see that. So the file that we wrote was, it should be in here. I know, yeah, I deleted the file. Okay, right. So yeah, what we should see is hello world 0, hello world 1, hello world 2. But that's not what we are getting out. So apparently we were expecting hello world 1, but we read hello world 0 again. Okay, so does anyone know what the problem is here in this? Is there a problem with the write or with the read line, or maybe in the constructor that causes us to read the same line again? And Mario again with the answer in the chat. Increase line number. Okay, indeed. So I have a method here to check the line number and seek to position 0 if the line number is 0, but I don't increase it anywhere. So if we want that code to work, then we need to add here self.line number plus 1, increase it by 1 each time, and then the code should work. And it does. Okay. Well done, Mario. Okay. So that's my short overview of Python unit test. So you should all have the examples by now. You should, in the repository that I linked to. So please experiment with it a bit if you want to know more, or yeah, or yeah, to create your own test suites for projects that you may be involved in. There is a lot more that we could talk about. I'm sure that Mario is a bit disappointed that I didn't go over mocking and interfaces specifically for unit testing, for instance, which you can also do in Python, of course. I didn't discuss interfacing with C or C++ code in Python tests. I didn't discuss many different aspects of the Python unit test framework that are all quite interesting. So I invite you all actually to look at the excellent online documentation for Python unit test. If you just Google Python unit test, then you will arrive in this page, and it describes very well all of the aspects of it, including the built-in command line interface that you can use for Python. So you don't even have to write a main method like I did. So you don't have to write this file or this file to run your tests. So you can just use Python/m unit test something.py, where this then contains the test cases. You have test discovery, so Python can automatically discover all of your test cases, so you don't have to manually put them all in a test suite and then forget to put one of them in the test suite and accidentally run less tests than you wanted. So there are multiple ways of doing that. So there's a lot of useful functionality that I skipped over. Yeah, you can specify here unit tested skip that you want to temporarily, you can use that to temporarily switch off a test, and so Python will automatically skip that test. So for instance, if you are working around some known behavior, that will be fixed in the future. So there's lots more in here that I can't hope to cover it all right now. So yeah, be sure to check the main documentation. Okay, that was my part of the course. So I will now hand over to Vitaly, who will be discussing how we use board farm with Python in the prplMesh project. So go ahead, please, Vitaly.
Can you see my presentation?
Yes, we can see it.
Okay, testing with board farm. First chapter is about board farm itself. It's just a framework developed by Qualcomm for testing open WRT routers. So exactly what we need.
We can't hear you, Vital.
Is it due to internet connection or something else?
Now we can hear you. So yeah, it was just you fell away for a second, but now it seems to be okay.
We can do a bunch of different stuff, like running tests on a specific board or on a specific board type, even flashing a kernel and so on. Well, it's basically all what I want to say about the framework, because we don't use it directly, but through different wrappers around it. But first, let's talk about pexpect Python module. Why do we need it? Basically, we, as humans, we type some programs in the terminal and read the output, and then type the next command depending on the output. So it's the same that this module does. As an example, I chose running a simple command on a router. So first we log into the router via SSH, and then write a program, a command. It's how pexpect equivalent looks like. We spawn a child kind of a process. We expect a prompt. When it arrives, we send the line if config blah blah blah. Wait for the next prompt and print the output. It's how it looks like in my example. Not very beautiful one, but it kind of works. We can use regular expressions with pexpect. So instead of printing the whole output of ifconfig, we can add a capture group here after init address and print just it. And we can expect several different outputs. In this example, it's example with from the actual prplMesh code. We run IW command on the router and check for one of the outputs. It's either connected or not connected. And we can also specify timeout and end of file as possible matches. Expect returns the index of the match. So if the output is connected, connectivity test passes, and if it's not connected or we don't have neither connected nor not connected in, I think the default timeout is 30 seconds, we return false. Next, it's prplMesh utility functions for testing. Check log is the first one. It just looks for a specific line of text in a log file. It's a very crude way to run tests. Don't use it. We had a lot of timing issues and false positive failures. But sometimes we have to use it, for example, for M2 settings. They are encrypted, so using a sniffer is not suitable. For check log, we supply the log file name. It's a log file for radio number 0. And we just do a text search for the line. If you can use, please use check CMDU family of functions. They look quite self-descriptive. For example, here we send the link matrix request. It's in the first line. We ask a controller to send the link matrix request here. It's what dev send 1905 does. We wait a second and we check that controller sent a single link matrix request message to agent number 1. We also can check that this message is well formed. For example, here we check that it has a correct TLV. Then we do a bunch of asserts. And yet another check CMDU command. So it's the preferred way to do it. Please use it. Okay, so let's write a new test. I chose an empty test as an example. So what you have to do is to inherit from a prplMesh base test and define run test command. Instead of pass, you can put any Python code like this or like this. It's up to you. Then you have to save it in within the Board Farm plugins directory structure. And you need to add your test to the test suite located here in test suites.cfg. Then, well, since the match request 1785 is not matched yet, we have to edit the DC test script manually. Here you put your test name. In future, you will do it by specifying a command line argument to DC test. That is called test suite. And then you can just wait for DC test to pass and to look at the exit code. Exit code 0 means that all the tests passed. If the exit code is different, like here, you can see a number of failed tests and the exit code is set accordingly. For the detailed result, you can look at tests underscore result.json. It has a short test summary and the result for each test. So in my case, I pasted an image with a failure, but well, here it passed. Sorry for that. And in future, we will have 2 more options for testing. It's northbound API. Northbound API is the main API to communicate with other applications that can use prplMesh as a plugin, or we can use them as a plugin. Since this API will be implemented in the future, and I think it's almost implemented, we would like to use it for testing as well. Also, Altron has a test setup for Wi-Fi routers that we can just reuse. This setup is bigger than we have in prplMesh, so it will be nice to have. Okay, so it's all for the presentation. Do you have any questions, or would you like me to run some code live?
Vitaly, can you tell me what the difference is between running the tests in Docker and running it on your device? Can you demonstrate that in any way?
Yes, at least I hope so. So let me log into the build server. Oh, okay, sorry. I don't have prplMesh installed here, so I cannot show it at the moment. But I can promise that if you change -n option in DC test, it will work.
Okay, so where is this defined? So if you specify something else there, where does it take how does it know where to connect to and what board to use and so
on? One moment. It's a file that shows how to use different devices. This configuration is for Docker Compose, and this one is for Netgear X40 router. It specifies the connection command. It's CU to use the serial port. And here we do nothing because we can just use a shell. We can also specify via the interface IP address. Like here, it's the same file, but just on GitLab. And everything else is the same. We use the same code, and it should work. More questions?
So I should note, like I mentioned, that board farm is based on unit test, and so you can use the same assert methods that I showed and the same concepts apply. One of the things with unit test is that you can define a run test method instead of methods that start with test. So that is also part of unit test and not necessarily something unique to board farm. So yeah, if you could show some more tests, that would be useful indeed. So maybe I'll just run through a couple of tests.
Let me use link matrix collection because I implemented the early version of this test. So in the beginning, we define two agents and a controller. Then we.
So one interesting aspect there is if you don't have two agents and a controller, then it will raise skip test, as you can see. So it will actually skip the test rather than failing it if you don't meet the prerequisites for running the test.
Yeah. Here we start sniffer. And here we ask a controller to send the link matrix request to the agent number 1. So it's the index of link matrix collection query. And here we have a TLV. Unfortunately, I cannot decipher it now.
Yeah, I was thinking it would be nice to have some kind of constants there instead of numbers, because it's a bit you have to know now what the 5 stands for, and TLV number 8. What TLV is that, and so on?
I think there are tests that use descriptive names for it.
I think that's generally better, but yeah.
Okay, we wait a second and then wait for one link matrix query message. This part is for humans. It's used when test fails. We print that the link matrix query is absent. And this part is for computer. So actually there is no much to explain here. The code is quite self-descriptive. We just check that messages exist in the sniffer DOM and that they have proper TLVs and properly formatted. By the way, here we use a human readable name for parameters.
Yeah, that's good. So if the method is check CMDU type single, what if you have multiple TLVs or CMDUs? Will it fail the test, or why is it single?
Let's check it. Yes, it checks that length of the CMDU array is 1. And to make this array, it uses check CMDU type method. What does it do? That applies a lambda function for each captured packet. It checks that source and destinations are okay. Message type is what we expect. And that the message ID is what we also expect or is not set. So if there are several packets and we check for only one, it will fail. And the rest of the test is, I think, not that interesting because it's just a business logic for this particular test.
It might be nice to go through it anyway, quickly. To just from a high level view, what are you testing? What does the test verify?
As far as I remember, it should verify that link matrix is just present as a TLV, but it's done here. And here. And this part verifies links. And well, to be honest, I don't know.
Okay.
Yeah.
So what is the general flow of the test? So if I want to test certain functionality, how do you approach it? How do you make sure that the CMDU is sent? How do you capture it? How do you then filter it or parse it? And how do you put that in a test?
First, you copy an existing test and remove everything except of run test method, like I showed in the presentation, like this. And then you put your code in the body of the function. So it's run test. Then you request for hardware. Use dev send 1905 method to make your device to send a specific message. And then you either check logs or check sniffer dump.
Okay, so that's indeed what I wanted you to explain a bit more, or again, so that everyone knows what you're trying to do here. Yeah, thank you.
And yes, if it does not work, try to put slips in your code. It's a workaround, but we have to do it sometimes.
Okay, any further questions?
So no questions.
Okay, so I expect everyone attending this presentation to then know in the future how to write Python tests. So yeah, Vladislav, you?
Yeah, I'm sorry, I have a question. Maybe I have skipped, but whatever. How to connect the boards to the board farm? And this is hard to do or not? Do you have an instruction of it and how to run the tests on boards?
So to do it, you need to add your board to a JSON file. It's here in prplMesh config.json. And you just edit some parameters here.
Edit parameters, or we can add the new one? Just, for example,
Yes.
copy the name and can we just copy this stuff, paste it, and change the name and other?
Yes, sure. But you will have to edit, where is it? Okay, to do it easily, please review this match request. In this case, you will be able to copy parts of JSON file and then use the name of it as a command line option. To DC test. So
Yeah,
it's how it.
Okay, okay. Please continue. Sorry.
If you want to do it before this match request is matched, you have edit sniffer, maybe this one. You have to edit run_bf. Here it's prplMesh compose that corresponds to prplMesh compose here. If you put Netgear Rux40 here, it will use this device. If you copy and edit it, it will use your device. Just don't forget to change its name.
Okay, but it's just for manual using, just for developers. But what about CI when we have, for example, 10 boards, and can board farm choose the board and run the test on that board? And
Actually, I don't know. Maybe it will be solved by collaboration with Altran, but now we just use Netgear device for board farm, and only for merge request I showed you.
So I think the approach that we will take is, like you saw in the test, we have a certain requirements, and if they are not met, then the test will raise skip test, right? So we define in the test certain requirements, like we need these boards, and you could even put something in there to make sure that they are real devices and not Docker, or that they have certain commands available, or you can test the command output. And if that's not met, then you raise skip test. And otherwise you run the actual test. And so on every configuration, you will run all of the tests. However, in some configurations, some of the tests will be skipped because the requirements are not met. So you can use the system to, so you can have tests that are specific to a certain test setup simply because they require so many devices that, or they require devices that other setups don't have. So I think that's the approach that we will take, at least to start out with. Does that make sense, Vitaly?
Yes, I just think about functionality that the board farm provides us. For example, we could just specify a board type.
Yeah. So another thing that you can probably use is we can devise a system with annotations. So you can say before a test, this test is a test specifically for this test setup, and then the framework it will automatically ignore tests that don't match, that don't run on that test setup, and will only run tests that do run on the test setup. So there are ways to do that, but we don't have that in place yet, I think.
Yes, and we will have to write IP addresses and so on manually for the JSON file. We will have several JSON files for for different setups and just choose the correct one.
Exactly. So the whole point of the JSON file is to abstract away that kind of thing. So the difference between setups. So the only difference between the only thing that determines if you can run a test on your setup or not should be which devices you have in that setup. So which IP address they have and how they are configured, all of that is abstracted away in the JSON file. And if the JSON file is correct, then we no longer have to care about that. It will not affect the test if the IP address is different.
How many setups do we have of bot farm?
At least one.
So the Docker setup you can run anywhere. So that's one that's defined. Then there is the one that Vitaly used for testing locally on his PC that you've seen here. We have one that's in the merge request that will run on CI. And we will have one in Altran that's specific for the Altran test setup. And yeah, we might add more in the future as well. So the one in CI will use, I think, also a RAX40, or was it using Turus Omnia Vitaly?
I used RAX40, but as far as I know, there are several routers connected to it.
Right. So I don't yet know which one we will use in CI, but yeah, it's all easy to change in the configuration file, in the JSON file.
Yes, and it's possible to change a JSON file for your local setup. You can just buy a few routers and play with them.
Okay, so Mario, Mila, if I ask you to write a Python test using board farm, you will now know how to do it, right? Or do you have any questions?
I think I will have, but I need to try firstly. So.
Okay, maybe I need to copy my slides to Confluence in this case.
That could be useful, yes. I shall also copy my two slides and a link to the examples to my Python introduction.
You hear me now, Frederik?
Yes, Mario?
Yes, I wanted to ask for documentation about board farm. The documentation that you read before you started working with it, because I tried to search it on Google and I only could find the repository where the board farm project is hosted on GitHub. Is there any tutorial, any book, something?
Okay, Vitaly, can you show us where you would look for documentation on board farm in general?
Actually, I would not look at the documentation because the documentation for board farm is just documentation for the framework. And if the end goal is to write a test, I don't think that it's needed.
How did you learn to write a test for a device? It was based on try process, or somebody explained it to you? How did you learn to do it?
Mario, I don't hear you well, but if I understand you correctly, the test for the device and for Docker is the same. Is it what you asked?
I mean, what are your sources of documentation? Did somebody explain it to you, or you tried, you guessed and tried what to do? Can you hear me?
kind of.
Mario asked, how did you learn how to write a test? From documentation or someone explained to you?
I would just suggest to copy paste an existing test and edit it.
Yeah, but this is about running it. So who explained to you how you run a test?
Raphael?
Okay. So yes, to answer Mario's question, yeah, it's just word of mouth, apparently. But yes, we will be updating documentation. If you want to help with that, then that's always welcome, of course. So that goes for everyone in this meeting.
And the next question. I'm working with my workstation, but test setup connected to the other PC in other room with others. It's just separate test setup, but I have IP connectivity with that. So can I run board farm on my PC using the devices from other room, for example, or other place?
You can definitely connect to your device using some kind of SSH tunnel. We have a connection command option. So if you find the correct one, it may work.
Yeah, you can set up some kind of SSH tunnel or whatever. However, I think it will be simpler to just run board farm on your test PC. And so the run board farm scripts will run on the test PC, and you can just call it over SSH. I think that's easiest.
Yeah, but test PC has 2 GB of memory, and I will build prpLMesh till tomorrow or the next day, you know. And I want to build on my PC, run from my PC using the devices out there. Okay, understood. Thank you. Need to try that.
Okay, are there any other questions?
Yeah, I'm sorry. And also, it's a bad idea to build the code on the test PC, because if you have the shared test setup with a lot of boards, and you can break the main PC and break the test setup. So
Yeah, but what you can do is you can build it somewhere else, then copy over the image and to the test PC, and then go from there, right?
yeah.
So that's what I expect will happen in CI as well. It will be built in a separate stage and possibly even on a separate computer, on a separate runner, could be. And then it will be passed to the test stage and run on the test PC. So yeah, I don't think the build PC and the test PC need to be the same.
Okay, thank you.
Yeah, thank you, Vitaly, for making the presentation.
And thank you everyone for visiting the presentation.
Yeah. So last call for any questions.
Not a question, but if you could update the Confluence, or at least the one that we have, it will be good.
Yes, I will do that.
Also, Mario asked, is there any documentation about setting up? I also want to know.
there is the link that I pasted. I think this is the only one that we have. This is mainly for testing, I think.
Okay.
Yeah, so indeed, it might be useful to just describe quickly how to set up a test setup. I mean, we kind of have it there, I guess. Oh no, well, you showed it a bit. You showed the JSON file, which I think is important.
Yes, it's the entry point.
Yeah, so we need to explain that a bit on Confluence as well.
Okay.
Okay, so yeah, if that's all, then yeah, thank you all for attending the course, and yeah, thank you, Vitaly, for helping me with this, and yeah, see you all later.
Thank you,
Goodbye,
Frederik
guys.
and Vitaly, for presentation.